Hello. The topic I'm introducing to you today is one of the analytically oriented modules, and it's also a part of UCSF-Stanford CERSI course titled Regulatory Science for Next Generation Diagnostics. My name is Zivana Tezak, and I'm a member of the personalized medicine staff within the Office of In Vitro Diagnostics at the FDA. I'm also a member of the Precision FDA team, and we have already actually developed some of the competitions that are mentioned in the title. And I will be using these past competitions to illustrate today's topic. By now, you are probably well aware of the research map for NGS informatics that was published in the April 2016 issue of Science Translational Medicine. And it was issued by the authors were UCSF-Stanford CERSI, along with the FDA co-authors and the members of the Precision FDA team. What you can see listed on this slide are 9 steps of this roadmap. And 5 on the right side are more, 5 on the left side are more analytical, and 4 on the right side are more clinically related questions. As I already mentioned, and what you see marked in red here, I will discuss analytical point number 4, which is titled here, Competitions to Compare NGS Pipelines. So next slide. So I mentioned Precision FDA in my opening. So what is Precision FDA? It is an online, cloud-based virtual research space for investigators, for software designers, for test developers to work together so that they can create open source tools, analytics, and so on to streamline the evaluation on NGS test performance. The ultimate goal of this Precision FDA platform is to foster innovation and to develop regulatory science around NGS tests. Since its launch in December 2015, we had more than 1,500 users from 600 different organizations join Precision FDA. In March of this year, the Global Alliance for Genomics and Health, or GA4GH, with 375 member organizations, chose Precision FDA as the platform for groups' benchmarking tools. So we were really excited about that. And in the April this year, Precision FDA earned 2016 Bio-IT World Best Practices Award for Informatics. Now, sometimes users join Precision FDA community, and sometimes they work in their private space, but they're not really sure how to best contribute in the public space. What do we want from them? What is this platform for? What regulatory research directions might be good ones to take? So one way to start seeding some of the ideas and to engage community members in common activities that can provide new insights and new data sets is to hold competitions where users can then contribute pipelines to analyze raw NGS data. They can assess how their chosen pipelines perform when compared to others who are also willing to play. So, of course, there are other and complementary ways of community engagement and interaction, and some of which are really just a different form of a challenge, such as recently held hackathons listed on this slide too. So, to engage users, to encourage sharing of data and ideas, Precision FDA has so far offered 2 different competitions. These competitions are aimed at motivating the community members to demonstrate what their tools are, how effective they are, to test the capability of the Precision FDA platform, and to engage community members in discussions and data analysis. So hopefully that will all provide new insights and serve as a comprehensive source of information about reference data sequences, existing software pipelines, new software pipelines, and so on used to analyze sequencing results. So this current slide is just an overview of both challenges, and I will describe each of them in some detail in following slides. The first Precision FDA challenge was termed Consistency Challenge, and it was announced at the White House Precision Medicine Initiative Summit held in February of this year. This summit was marking 1-year anniversary of the launch of Precision Medicine Initiative. The Consistency Challenge was open for competition for 2 months, and it closed in April. There were 21 entries from 17 submitters. Participants were given 2 data sets of whole genome sequences from a known human sample, which is a genome in the bottle sample called NA12878. Now, this sample was sequenced at 2 different sites. One site was Garvan Institute in Australia, and the other one was a company called Human Longevity in California. So those 2 sites generously donated the data from their sequencing to Precision FDA so we can use that in the challenge. Challenge participants were instructed to use the informatics pipelines of their choice, so their own or some other ones that they choose, to see if they could produce the same results when running it twice on the same file. So they could run twice, let's say, Garvan file, and then to check for consistency between their results when using sequencing files from Garvan site versus the HLI site. By supplying FASTQ datasets and a comparator for VCF results, this challenge provided a common frame of reference so that we can measure some of the aspects of reproducibility and, to a lesser extent, accuracy of participants' pipelines. This slide shows you the overview of the consistency challenge results. The data sets and the results are available on Precision FDA website, and I'm giving you the link at the bottom of this slide. The table you can see on this slide is a screenshot taken from the challenge results page. It summarizes the results, lists recognitions, and discusses key conclusions from this first challenge. Challenge results were announced at the Big Data and Biomedicine Conference by FDA Commissioner Dr. Califf in May of this year. On the top right side of this slide, you can see a top overall performance award. So this is how the awards for the challenge were. They looked like this. This was one of the 3 top performer awards that Dr. Califf handed out. Besides this award, we also awarded top reproducibility performance for achieving the highest concordance and determinism, as well as top accuracy performance. We also recognized a number of deterministic entries, as well as entries with high concordance, high recall, or high precision. Since recall and precision terms used on Precision FDA are terms commonly used by NGS software developers, but not necessarily harmonized with definitions used by FDA, by ISO, or CLSI, you can see in the lower left corner on the right, the lower right corner, of the slide, some quick and easy explanations for these terms that Dr. Taha Kashut, Precision FDA founder, has provided during award announcements. The second challenge, the Truth Challenge, was designed in collaboration with the Genome in the Bottle Consortium, National Institute of Standards and Technology, or NIST, and the GA4GH. And it opened immediately following the closing of the Consistency Challenge. The goal of this Truth Challenge was assessing the accuracy of informatics pipelines when analyzing a human sample whose truth data is unknown. So that was very different from the first challenge. Participants were invited to test their informatics pipelines on 2 data sets. One was from the well-characterized genome in the bottle NA12878 reference sample, so the same sample as in the first challenge. And then another was different sample. It was a new reference sample termed HG002, or human genome number 2, I think, which the truth results of this sample were unknown during the time of the challenge. So the thing to remember is that researchers from around the world use NA12878, so the first sample, as training data sets for assessing pipeline performance. And a lot of NGS data analysis software has been tuned to NA12878. So what made Truth Challenge interesting and different was that challenge participants had the opportunity to test the performance of their NGS pipelines on a new reference sample data set without knowing the truth up front. So this slide shows the results. The Precision FDA Truth Challenge ran for a month from April 26 to May 26, 2016. And it was giving participants this unique opportunity to test their pipelines on the new unknown, the new data set with unknown truth. Now, the truth data that was released by Genome in the Bottle team immediately after the closing of the challenge on May 27, so next day after the challenge closed. We were very happy to see the number of challenge entries double when compared to the first challenge. We received 35 entries, and not only from many who participated in the previous challenge, but also from a number of first-time participants. Some participants showcased their developing new methods. Others used existing methods to see how they perform in this particular environment. I have to say that for both challenges, we are extremely grateful to all participants for their willingness to share the results, to contribute to this effort publicly. Now, working together with the GA4GH team to test their new version of data comparator that was still undergoing updates as the challenge was running in order to analyze the challenge results has been an incredibly rewarding learning experience. The collaboration that we had resulted in using of a particular methodology for comparing VCFs and counting results, and this was finalized and tailored for the needs of this challenge as we were trying to understand results. And this hopefully may form the basis of other comparisons in the future. And the comparator is available on Precision FDA as an app. This was the first time, as I mentioned, this new, more granular comparison methodology has been applied. Our evaluation against the HG002 truth data using this new GA4GH tool has produced results across different variant types, such as SNPs and indels, different variant subtypes, such as insertions, deletions of specific size ranges, and different genomic contexts, such as whole genome, coding regions, non-coding regions, and so on. And this has led to thousands of numbers per each challenge entry, which we made available for further analysis on the Truth Challenge results page. It's available as an interactive data explorer, and on this slide I have provided the web link for you so you can go and play if you would like to. Now, we've chosen 6 metrics: F-score, recall, and precision across SNPs and across indels in the whole genome to use as a basis for handing out awards and recognitions. But I want to say that these results are by no means the final word of analyzing this incredibly rich data set. And we consider the data set that resulted from this Truth Challenge to be really the ultimate reward. And we have already heard that some people have been trying to reanalyze on their own. Given the originality of the truth data and the comparison methodology, we fully expect and encourage further ongoing analysis of this data set, and hopefully this will lead to improvements in the benchmarking methodology, the truth data, and the definition of comparison metrics. Working on this challenge has actually already led to improvements in both GA4GH data comparators or comparator software prototype and to the benchmarking metrics. So what do we see as ways forward? I described 2 initial competitions, and you may be aware of the recent Appathon series. We're also asking the community to design and contribute some of our further competitions. So we're giving you all if you have some ideas, please come to us and propose some of the further competitions. Also, having a leaderboard to track continuous refinements to the software and apps added to the platform is another way to keep improving on existing challenges and contributions, improving on ways to analyze the data, adding new or improved apps. We see conversations on discussion forums and social media outlets as another complementary ways of engagement, crowdsourcing, and moving the field forward. And we are looking to you all to make for many, many great ideas to come. And on the last slide, I'm providing several ways of contacting us, both Precision FDA team as well as PMI team, either by emails, social media, web pages, and I have also listed my email address. So please feel free to contact us with any questions or ideas. We are looking, this is a community platform, and we are looking to the community for new ideas and for ways to move forward. Thank you very much.